Hello, everyone. Confidence interval estimation and hypothesis testing. Today, we'll walk through some key statistical concepts using practical examples, including how to calculate standard errors, interpret confidence intervals, and test hypothesis with the real data. So, me and my teammate Shubhankar is gonna present it. And the second, let's move on to the second slide. So here we are explaining the concept of standard deviation of sample mean, also known as a standard error. So we calculate it by dividing the population standard deviation by square root of the sample size. In our case, with a population standard deviation of 180 and the sample size of 345, a standard error is approximately 9.69. So this means that average of our sample means will be typically vary about 9.7 units from the true population mean of 150. A smaller standard error indicates more consistency and reliability when we repeat sampling. So let's move on to the problem statement. Here, from the population with a mean of 150 and a standard deviation of 180, we draw a random sample of 345, and the task is to compute the standard deviation of sample mean and interpret what it means the context of sampling. So let's move on to the formula and calculation. So here it shows the actual calculation step. So using the formula, we divide 180 by the square root of 345 to get the standard error of about 9.69. This value tells us the degree of variability we can expect from our sample means when estimating the population mean. Um, so let's move on to the next slide. So here we are talking about random sampling, independence, and normality of sampling distribution. So when constructing a 95% of a confidence interval, certain assumptions must be met. First, the sample must be randomly selected and representative of the population. So second, observations needs to be independent from one another. And third is due to the central limit theorem, with a large sample size like a 345, the sampling distribution can be assumed to be approximately normal. So the next slide is that's going to be presented by Shubhankar.
Okay, thank you. So now let's move into hypothesis testing. Here's a scenario. We analyzed 32 workers with a sample mean of 42, 1 hours per week, and a sample standard deviation of 10.4. The claim is that the population standard deviation is at least 13 hours. So we set up our hypothesis. The null hypothesis assumes sigma is equal to 13, while the alternative suggests sigma is less than 13. Since this is a testing variability, we will use the chi-square test. Here's the chi-square test in action. Using the formula, we compute x square as 19.84 with 31 degrees of freedom. The critical value at a 5% significance level is about 19.28, and our p-value is around 0.061, which is greater than 0.05. This means we fail to reject the null hypothesis. In other words, we don't have sufficient evidence to conclude that the population standard deviation is less than 13. And for this study, we used these three references. Thank you.